you for the introduction. Okay, so my talk today is about an European project that is running. I'm not the coordinator. The coordinator couldn't make it to the summit today, so I'm presenting on his behalf. This project is about open source and cloud. And let me just give you like a small context. The cloud market is a big asset for Europe. The cloud market is expecting to increase, but there's a big problem for the European community, is that most of the ICs we use in cloud, they are not produced in Europe, and basically US and China are the main players. So the European Commission is trying to put an effort to gain some strategic asset in this domain. And well, we know that RISC-V is one of these assets. RISC-V is open, is royalty-free. There's a lot of potentiality in scalability. We can improve the instruction set. We can add new facility. It's energy efficient. So that's why, from some perspective, the European Commission has put a lot of investment in building processors that are based on RISC-V. But now, just building processors is not enough if you want to penetrate the cloud market. And there are some important challenges. First of all, the entire ecosystem that is around RISC-V is not consolidated. It's still moving, it's still improving. And for a market like cloud computing, where people want services that need to be reliable, this is a problem. Second problem, the availability of hardware is still limited, especially if you want to go for server-class processors that we need to run cloud applications. And we have a big issue in hardware and software compatibility. So I may say that probably in terms of hardware, we are still not there. But we need to be ready when the hardware will be available, and the hardware will be available soon. An answer to these challenges, one of the answers that the European Commission funded for these challenges is the VitaminV project. The VitaminV project is a project that focuses on providing cloud software running on RISC-V. So this is a nice picture we took in Barcelona last year during the kickoff meeting. This is the entire team. Actually, the team is growing every year. VitaminV started last year, 1st of January in 2023, so we are just in the middle of the project. We are 10 partners. As you can see, more or less we come from the north to the south of Europe. The project is coordinated by the university in Barcelona. The BSc is part of our consortium. It was nice to see the VitaminV logo in the previous presentation. We have Politecnico di Torino and Links in Italy, in Greece, University of Athens, ECCS and Espasis. We have 0 Point from Sweden, and we have Virtual Open Systems from France, and Semidynamics again from Spain. Now, let me try to explain what we are trying to do in VitaminV. So we are trying to address the entire cloud stack. And of course, if you want to work on cloud stack, you need to start from hardware. And in VitaminV, we start, thanks to our partner Semidynamics, we start from an available core. And we have been working to improve the capabilities of this core with all the extensions that we need to run cloud applications. And one important point of this core is that it has been synthesized on FPGAs. And this is an important building point, because we want to create execution environment to run cloud applications. And we have an environment that is composed of 3 parts. The first part is the simplest. We provide Chemo to our developers, so they can start develop even if the hardware is not that ready. But Chemo is not really good if you want to analyze performances. So for performances, we use time-accurate simulators like Gen 5. But finally, we want to test on real hardware. And so we have a core that is running on FPGA, and actually we can deploy it on Amazon AWS F1 services. So we can really emulate multiple nodes, and we can emulate a cloud infrastructure. So based on this virtual environment, we are working to port main cloud software on RISC-V. But to port software, we need compilers. And the choice we did in VitaminV is to base our compilers on LLVM. And BSC is our main player here. They are supporting us in porting the different languages we need to compile the cloud stack. And we are trying to support all main cloud infrastructures. So Kubernetes, OpenStack, and also serverless based on Kata containers. So it's a long porting process. Somebody may think that it's just about taking the code, compiling, and having running, but that's not true. There are many issues. There are libraries that need to be adapted, and there are problems to be solved. But luckily, we are in the middle of the project, and we start to have demos and applications that are finally running properly. And on top of that, we selected some key applications to demonstrate the capability of our infrastructure, like TensorFlow to run machine learning applications, Spark, OpenFuzz, and many other applications. This is not all. When you run cloud applications, you need to trust the applications, and we want to leverage the open architecture of RISC-V, so we can somehow influence how the architecture will be developed. And RISC-V is developing powerful hardware monitoring inside our chips. And we want to use them to build a facility to profile our programs, to profile their performances, to use it to detect bugs and even detect malwares. If you were here yesterday, there was a poster presenting some activities, and I think you can find the poster also on the Summit website. So using this big ecosystem, what we did is we will try to handle different cloud setup. And basically, we are working on 3 very different setups. The first one, what we call the classical cloud. That's the oldest way we deploy applications on the cloud, and it means we use OpenStack to run entire virtual machines. So every virtual machine is running the entire stack from the operating system. We are working with Linux and all the applications. The second scenario we are targeting is what we call the modern cloud. And if you work in the cloud domain, you know that people are leaving virtual machines and are moving to containers. And here, Kubernetes is the main technology to deploy containers. So we are testing applications that work based on containers. And finally, the new trend in cloud setup is to what we call the serverless setup. Here, we actually try to run very light applications without running servers. This is again is based on Kubernetes and Kata containers. So we are trying to use the entire stack we are porting to and test it in these 3 different scenarios. Okay, my role today was not to explain how the different technologies we are developing work, but just to make you aware of our project and stimulate your curiosity. But if you really want to know how things are working in this domain, we organized an event on Friday. So if you are here on Friday, you are all invited to join our event. And yeah, you can see there are many VitaminV players that will talk and present their results. But the event is not just limited to VitaminV. We have many other speakers that will mainly focus on whatever is the advancement in open source software connected to RISC-V. And well, if you are interested in the development of our project. Here you can find all our channels. We have all our publications or our tools and advancements that are posted there. So you are welcome to join our social media and get updated on all developments we will have in our project. And that's it for me.
Thank you so much. We have time for a couple of questions. I don't see a thing. There's one over there.
Hi. What I want to ask you is, I mean, you mentioned several of the different cloud solutions out there, and how are you collaborating with more industrial or more commercial, like applications or providers? Like I'm thinking about, you mentioned Kubernetes as a container. Are you talking as well to Nutanix or, for example, VMware for doing some testing with them?
Not yet. Not yet. At the moment, we are in contact with the mainstream open source maintainers of the different projects. So our plan is to push our portings directly into the main repositories of the project. But testing with the main players is still not in our target. Also because the real problem is that we need also the hardware to test it. So right now we have hardware in our project, and we can test applications with our hardware. But whenever we need to interact with external players, they need to have some compatible hardware. That's for the future.
So still time for a last question. There at the end.
Thank you very much. Really exciting. So my question is, can you give us an outline of what are the future roadmaps? For example, what can we expect enabled in a year, in 2 years, in 3 years as part of VitaminV?
Okay, our project is going to finish at the end of the next year. So the promise we did to the European Commission is to complete the porting of the entire stack. And right now we are fully in line with our roadmap. So the expectation is in 1.5 years is to complete the porting at least of the 3 main elements of the infrastructure. So Kubernetes, OpenStack, and Kata containers. We already have demos that are working. So it's about improving the stability and the performance. We are already in a good stage with porting all the compilers. For example, we had to adapt the Go compiler to compile Kubernetes, RISC compiler to work with Kata containers. So this is our current target in 1.5 years, and hopefully, if results will be good, there will be a chance to continue with future projects. But so far, we cannot promise anything.
Thank you very much for this interesting talk.